So I want to look at another set of linear graphs in context and go through a few of the skills that we might need to find the equations and the intersections. So I might do these ones using the calculator just because we might need a bit more practice with that. But remember, you could use y equals mx plus c. So using the calculator, if I want to find the rule of these graphs, I need to pick 2 points on the graph. So for graph A, I'm going to use 0, 10, and looking really carefully to see when it overlaps another grid perfectly. It looks like it does it there at 2, 20. And for graph B, halfway in between, but halfway between 20 and 30 is going to be 25. And another spot where it crosses that grid perfectly. I'll say this one out here looks pretty good. So I'll use 0, 25, and I will use 6, 30 as my points. So going into Stat, Menu, I'm going to enter in the 2 points for one of the lines, so that's 0 and 10 for graph A, and the next point on graph A is going to be 2, enter 20. Graph 1, calc x because it's linear. I can see my r squared is 1, so that's a good thing. And my gradient is going to be 5, and my y-intercept is 10. So for graph A, my rule is going to be y is equal to 5x plus 10. And putting it into context, I've got number of booklets and cost, so I'm going to use c is equal to 5 in plus 10. And again, I can see that my y-intercept is 10 and my gradient is actually 5 over 1. So I could have done that by hand. So for B, I might go ahead and just do this one by hand. C is equal to my gradient, or my y-intercept is plus 25. My gradient here is going to be a rise of 5 over a run of 6. So 5 over 6. And if you don't like that as a decimal or as a fraction, we can do that as a decimal, and we can also see what we get out of here. So 25 and 0, and this one is at 6 and 30. Graph 1, calc x 0.833333. So another way that you could write that, if you want, is the decimal. C is equal to 0.833 in plus 25. Alright, so those are our 2 rules, and one other thing that's obviously going to be important for us to calculate here is that intersection. So these are my rules, and my intersection. Again, this is when those 2 lines are actually equal to each other. So if we think about our context here, we're talking about the cost of printing booklets. Maybe this is company A and this is company B, and I'm trying to decide which company to use. So I can see that at some point they actually cost the same amount to print booklets, and I can see that because of the intersection. So where they intersect, it's the same cost for a certain number of booklets. And if we look at this here, well, 2, 2.5, 3, 3.5. Not that you would ever print 3.5 booklets, but there is that point where it transitions. So maybe it's not exactly 3.5, but it looks pretty close to that. So let's calculate exactly what it is. So my intersection, a couple of ways I can do this. One is by hand. I know that these 2 equations will have to be equal to each other. So I would say 5n plus 10 is equal to 5 over 6n plus 25. And to solve this using algebra, minus 10 from both sides, 5n is equal to 5 over 6n plus 15. I might do it this way to get rid of the 6 on the bottom, times everything by 6. So I've got 30n is equal to 25 plus, sorry, not 25, 30n plus 5n plus 90. So minusing 5 in from both sides. 25 in is equal to 90. Divide by 25 and divide by 25. In is equal to 90 divided by 25. And again, you should have your calculator, for that, which I've lost. So 90 divided by 25, 3.6. Okay. Your other ways to do this, of course, would be using your graphics calculator. And one thing that we can actually do is, if we recognize that these two equations are going to be equal to each other, we can use the equation solver. So look for equa on your calculator. And we'll use solver, so hit F3 for solver. And you can type in exactly what you see, which is 5. Remember, we always use the X underneath the red button. Plus 10 is equal to, and equals, you can see it here above the decimal. You would go shift equal 5 divided by 6 times x plus 25. Enter. And then you have to make sure you hit solve to solve it. And you can see there that I get 3.6 as well. And another way to do this could be inside of graph. If you were in graph, enter in your two equations, 5 in plus 30, plus 10, and 5 divided by 6 times in plus 25. Go ahead and draw it, and remember, you need to make sure you can see it all, so let's change my view window to match what it says on my graph, which is from 0 to 10 and from 0 to 60. So my min x will be 0, and I'll go to 10, and my y min will be 0, and I will go up to 60. And you should be able to see your graph there, and now I can use gsolve, and remember ISCT is my intersection. So there we are, and I can see that it's at 3.6 at a cost of $28. So that's the other thing to watch out for. So C is equal to 28. We need to make sure we solve for both of them. And again, if you're doing that by hand, we would get that from plugging in 5 times 3.6 plus 10 would be equal to our cost of $28. So I know my intersection is at 3.6 booklets and $28. And again, putting this into context, it doesn't really make sense to talk about 3.6 booklets because you'd never print 0.6 of a booklet, but we know that that's when the transition happens. So one thing that we might want to talk about is, if I was going to compare and contrast these graphs, I'd want to say that company A costs more at the start with a fixed fee of $10. So basically what we're saying by that y-intercept is that before they print any booklets, if you're going to run a job with them, there's a $10 fee that you have to pay. Fixed fee of $10 shown by the y-intercept. B, oh sorry, so A costs less at the start with a fixed fee of $10 shown by the y-intercept. B costs, I might, instead of say costs, say charges a fixed fee of $25. So we can see at the start, company A is the cheaper one to use. Company A charges more per booklet. And how would I know that? Why am I saying that they charge more per booklet? Well, one thing that I notice is that the line is steeper. It increases more, and my rate, my gradient, is going to relate to the rate, which in this case is the units of y per x. So the rate is cost per booklet. And if we look at our gradient for equation A, it's going to be $5 per booklet, and for B it is 3.6, so $3.60. Oh sorry, not $3.60, 0.833. So they charge 0.83 dollars per booklet. So I can see that Company A is much more expensive per booklet. So A charges more per booklet at $5 per booklet compared to B at 83 cents per booklet, shown by the gradient. So the intersection, how I would talk about that is that it is cheaper to use A to print up to, so the intersection happens at 3.6. So is it cheaper to print at 4 books if we were it around? Well, it's not. For B is now cheaper. But because this is in between the number of booklets, we'd say we'd kind of round it down to the nearest booklet. So it's cheaper to use A to print up to 3 booklets. And after 3 booklets, it's cheaper to use B. And this would be shown by the intersection at 3.6, comma, we said it was 28. So putting that into context, what that intersection actually means here is that, yeah, if you were theoretically going to print 3.6 booklets, it would cost the same for either company. But because it's 3.6, we need to round down. Where's the nearest booklet here? And it's going to be at 3. So for less than 3 booklets, A is cheaper to use, and for more than 3 booklets, B is going to be cheaper to use. So after 4 and above, B is going to be cheaper to use. So that's how we'd put this problem into context if we were going to be talking about it.